All right, welcome back, students. In this video, we're going to cover Module 6, Module 10, Topic 6. I'm reading it backwards. Tangents and secants. Standards in this video are GR 6.1. So this is, mathematical and real-world problems involving the length of a secant, tangent, or segment of a chord in a given circle. 6.2 involves measures of arcs and related angles, and 5.3 construct the inscribed and circumscribed circles of a triangle. Okay, so you'll notice these last couple of videos, the last 3 or 4 for Module 10, I'll have about the same standards. So objective, you guys are going to solve problems. Oh, sorry for the shaking. You guys are going to solve problems using relationships between circles, tangents, and secants. So, give me just a second. I've got my mouse pointed at the stop button, and we don't want that. Oh, jeez. Hopefully y'all can't hear a kid yelling at the dog. All right, so we're on page 5 of the Module 10 Part 2 packet. So, warm up. What's the measure of arc BC? All right, so arc BC is right here. Whoop, way outside the line. Sorry, this new camera situation. Anyway, so this arc is associated with this angle. We know that the arc's worth twice the angle. We learned that in the previous topic. So measure BC is going to be 2 times the measure of angle. I'm just going to say A, but it would be CAB or BAC, but we're just going to say A because we all know what we're talking about. Okay, so that's 2 times, this is 45. 2 times 45 is 90. So the measure of arc BC is 90 degrees. All right, number 2. What is the measure of angle CMB? So this angle here, CMB. So you see it's associated with this arc. Just kind of barely color it in. Okay, so the angle, if the arc is twice the angle is half the arc. So the measure of angle CMB equals 1/2 of the measure of arc. We'll just say CB. It doesn't really matter, but it's going this way. We'll say CB. All right, so 1/2 of 98. So half of 98, that's 45, and so it's 49. So the measure of angle CMB is 49 degrees. All right, so what is the measure of arc AB? So arc AB goes with angle D. Excuse me. So measure of arc AB is 2 times the angle. So 2 times the measure of angle D. 2 times 43, which is 86 degrees. Okay. Excuse me. Okay, scooting down the page. Sorry, I'm going to try to limit how much I move if I can. All right, so again, page 5, underneath the warm-up, tangent, secants, and angle measures. So a secant is any line array that intersects a circle in exactly 2 points. So, hold on, let me just... Exactly 2 points. So over here, lines J and K are secants of circle C, because they go through it. When 2 secants intersect inside a circle, the angles formed are related to the arcs they intersect. So New and exciting stuff below. All right, so theorem 10.14. If two secants or chords intersect in the interior of a circle, then the measure of each angle formed is 1/2 the sum of the measures of the arcs intersected by the angle and its vertical angle. So I know that's a lot of words. So if it's located inside the circle, the measure of each angle, so you see there's going to be two angles, the measure of each angle formed, let me flip this over, is 1/2, so 1/2 the sum of the measures of the arcs intersected. So we're going to, let's see, how are we going to do this? Just stand by below. Sometimes the words, I kind of trip over the words a little bit. So that's why I try to break it down a little bit for you guys, because I don't really speak, Pythagorean or whatever. So we'll try to learn it in English or something like that. Okay, so find the value of x. So x is right here. It's a little small. So they tell us that the interior of the circle, so each angle formed, so these two angles, is 1/2 the sum of the measures of the arc intercepted. So that would say, so this angle x, or x is going to equal 1/2 the sum. So we're going to add 117 plus 63. Okay. So this angle is worth 1/2 of the sum. So we're adding these two together and dividing it by 2 because we want half of it. Okay. So 117 and 63 is 180. So half of 180, I hope you guys know this by now, is 90. So x is 90 degrees. So this guy is actually like that. Okay, all right, let's see. Number 2. Find the value of x. So x is here. So the angle is 1/2 the sum of these two arcs. So 47 plus 116. So 47 plus 116. Shoot, I think I meant to leave that for a you do, but it's all right. We'll do this. So it's 163. So 1/2 of 163 is 81.5. Okay, let's flip over to page 6. Try to keep it straight. Next page. Sorry about that. Okay, so number 3. Just to remind me, we're doing, this is the I do. Let me just check something because I'm sure this doesn't get anything crazy. Yeah, these are okay. So we'll do 5. 6 is a you do. So I'll do 7 and 8. We'll leave 9 as the you do, and on the back page here, just real quick, the number 10, I think. Oh yeah, on the back page there. I have to do all of those because they're a little more tricky. Okay, so wait a minute. Where did I go? All right, so we flipped from there. Yeah, so flipped over there. Yeah, you see it's 4 pages, so. All right. Yeah, here we go. Okay. Sorry. Trying to get straightened out here. All right, moving on. Number 3. Page 6. Solve for the missing arc measurements. So, this is kind of hard to read, but so the measure of MF, I'm going to write these because you guys know I can't see. F, what's that? Oh, Lord. F, what is? Oh, that's a U. And that's a L. Excuse me. Oh, it's T in the middle. Okay, sorry. So, measure of MF. Let's call it pink. So, MF. It's 91. 91 degrees. And the measure of angle MTF. So, this angle. This angle. Sorry I didn't make the same color, but that's okay. You guys will be all right. 82. Okay. They want to find... I'm going to find a different color. They want to find LU. So LU. Okay. So we know that the angles are half the sum. So how do we do this? How do we do this? So we got 91, 82, and we're looking for this. We're looking for X. We're always looking for my X. Joking. So, that's a math teacher joke. So I'm going to make this, just make it a little different. There we go. So, alright, so we know that the measure of the angle, in this case MFT, would equal 1/2 of the sum of these two. All right, so 91 plus X, okay? The angle equals 1/2 of the sum of these two guys, okay? I already plugged it in, and I didn't mean to do that, but let's just write above it in red. And I meant, yeah, and I'll put the measure over here. So 82 is the measure. It's 1/2, so 91 was that MF, we'll say, plus LU. That's this guy. So this equals the sum of 1/2 of these two. Okay. So now let's do some math. Go back to this. So at the 82 over there, I'm going to get rid of the fraction. So I'm going to multiply both sides by 2. This is going to cancel this out. And 82 times 2 is 164. So that leaves 91 plus X over here. So I'm going to get rid of 91. Subtract it from both sides. It cancels here, just leaving X. And then 164 minus 91 is 73. So X equals 73. So we just did the formula in reverse, and I know sometimes it kind of blows your mind a little bit, but set this up the same way. EM, so they give you this, they give you this angle, they want this side. So this should be half the sum of these two. So there you go. Good luck. All right, scooching down a little bit. Still on page 6. Theorem 10.16. If two secants, a secant and a tangent, or two tangents, intersect in the exterior of a circle, so outside, right here, then the measure of the angle formed, so this angle, or that angle, is half the difference between the intersected arcs. So you're going to subtract these two guys, and it's going to be half the difference of those. So changing up just a little, but just stay with me. So this time they are telling us consider the circle below AP. You know, I like the colors, you guys. So AP. What the heck? AP ARP, that's the little one. You can tell by the little number. That's the big one. You can tell by the big number. ARP, that's for the old folks, AARP, is 282. Okay, so write this in pencil. So this guy's 78. This one's 282. This is the angle. So the angle is 1/2. So the angle is 1/2 the difference of the measure of the intersected arc. So we have to subtract, we have to have a positive number. So you put the big one, subtracted the little one. Okay? So 1/2, well, first off, 282 minus 78 is 202. I'm sorry, 204, excuse me. And 1/2 of 204 is 102. So that makes this angle 102 degrees based on this information. You're going to do the same thing over here. Here's your angle. Your angle is half this minus this. So just big number minus x. So we've done enough. Do this over here, please. Please try it. Okay. If you write that class, well, you guys are in my class. I know there's some that may be watching in other classes. That would be interesting. Anyway, all right. So, excuse me, 1 second. All right, theorem 10.15. Still on page 6. I'm trying, you guys. If a secant and a tangent intersect at the point of tangency on a circle, then the measure of each angle formed is 1/2 the measure of its intersected arc. Okay, so 1/2 of the intersected arc. Let's see. Each angle. All right, so that I'll show you in number form here momentarily. Okay, adjust my glasses. All right, so number 7. And these guys are going to work the same. Actually, I'm going to do these two. You guys will work on that one. All right, so number 7. Given, let me get the colors out here. So they tell us that BDC, so B from B to D to C, all the way around there, that's 240 degrees. So that whole pink there, 240 degrees. Solve for angle. So let me make this purple. Solve for angle BCW. All right, so it says here. So their point of tangency. This is a tangent. No, I'm sorry. This is a tangent. Touches it in one spot. This is a secant, touches it in 2 spots. They have a point of tangency right here, point C. So the measure of each angle formed, so this would be one of those angles, is 1/2 the measure of the intersected arc. So for this, the measure of angle BCW is going to be 1/2 the measure of, and I'm sorry to get over here to the other side, but BDC. Okay, I'll scooch over. So we're going to have 1/2 of, so the measure of that is 240. 1/2 of 240 is 120 degrees. So the measure of angle BCW, so this angle is 120 degrees. If you look at it, you're like, oh, well, that's half of that. Right. But sometimes the words are a lot. Okay, number 8. So we're going to find the measure of JKL. So, well, they want to find the measure of arc. JK KL. That's so weird. How does that look? Well, and it's because, yeah, they actually want it the other way. This should be arc, measure of arc JL, not, which they should both, if you say JKL, see, I don't know why L would be involved in that, because it's, yeah, that's weird. Well, we're gonna do the other way. We're gonna call it JL, and we're gonna make it this, and it's, no, that's not right either. It's JK. Oh, jeez. So just take the L out of this. It should be JK. Oh, jeez. JK. So I got to make this blue. We got this box here. That's where we get our angle measure. That's why I knew the problem's not right, because see, if this intersected arc, it's double the angle. This is 90. This should be 180, which is half of a circle. But they're asking the other way. Well, it goes past that. It has nothing to do with this angle, so we're not, unless I'm looking at it wrong. And if somebody tells me I'm wrong, that's fine. Let me know in the comments or in class, whichever. So for here, the measure of arc JK is going to be equal to 1/2. Oh Lord, we're over in this side, but we're in the measure of angle KJH, which is 1/2. No, it's 2 times, because it's 2 times the angle, 1/2 the arc. Sorry. See, the angle is 1/2. The arc is 2 times. So it's 2 times 90, which is 180. Okay. So let's scooch to the bottom. We got a little bit of notes here. Bottom of page 6. So tangents, secants, and segment lengths. So special relationships also exist for the segment lengths of 2 chords when the 2 chords intersect inside a circle, or when secants and tangents intersect outside a circle. All right, so let's try to make this. So when the chords intersect inside the circle, and then when it's a secant and a tangent, they intersect outside the circle. All right, so when 2 chords intersect inside a circle, each chord is divided into segments called chord segments. A secant segment is a segment of a secant line that has exactly 1 endpoint in the circle. An external secant segment is a secant segment that lies on the exterior of the circle. So, I mean, So secant segment has one endpoint inside, and then external, it just means outside. So it should be easy enough to remember. Okay, page 7. So a tangent segment, so this is the rest of the notes. It kind of cut off into the next page, but it's a segment of a secant with 1 endpoint in the circle. So tangent segment has 1 endpoint inside the circle. Secant segment has 1 endpoint in the circle, and then exterior segment, I think it was what it said. Hold on. Flip over. External. All the way down there. External. Sorry. Okay. All right. So, Theorem 10.17, segments of chord theorems. Segments of chords theorem, excuse me. If two chords intersect in a circle, then the products of the lengths of the chord segments are equal. Let me find my pencil. So, what that's saying is AE times BE is equal to DE times CE. So let's see. So AE is the whole thing. The products of their lengths. So the products of the lengths. So this times this times this. And I'll just do purple beside it, is equal to the chord segment. All right, so D, wait a minute. What? AE, I messed that up. So, yeah, so that side, this side will be, so I'll just cover it up. Nobody will ever know. So, purple times purple is equal to pink times pink. Okay. Theorem 10.19. So if a tangent and a secant, so tangent touches it one time, secant touches it twice, intersect in the exterior of a circle, so out here, then the square of the measure of the tangent is equal to the product of the measures of the secant and its external secant segment. Okay, that's a lot. That's a lot. That's a lot. That's a lot. Give me 1 second. Let me find my notes from last year so I can. Where are we at? Okay. Yeah, math. When it's a black and white copy, you can't tell. So, we're going to square. Well, let's do this. Hold on. Sorry, I don't mean to have so much time, guys. I know you can fast forward though. So AB squared, which is going to be pink. So the square of that is equal to AC, and I'm going to have to go weird here, times AD. So this part times the whole thing. Hopefully you can see that. Yeah, let me just kind of go above here a little bit, and I apologize for all the. So the purple times the green is equal to the square. So it's this squared, and then purple times green. So, all right. So we're going to kind of keep these, well, can't keep them all in view, but we'll try to refer back or point back if I need to. All right, so number 10, given the circle below, chords FG and HI, let's see. Oh, given the chords below, I was like, where's the rest of it? Find the length of IJ. So this one. Let's see. Yeah, all right, so. Let's look at it close here. So FJ, so this guy, times JG, this guy, so G, is going to equal IJ times JH. Okay, so Sorry to go over the line again. All right, so FG is 36 times JG is 11. That's going to be equal to IJ, which is X, times JH, which is 10. We'll just do... keep it. So this is X. I'm just going to make it purple X. Okay. And we'll just do it like this. So here's our, this is 10. This is 10. So hopefully this will help you guys. So this is what we're doing. This times this is equal to this times this. All right, so 36 times 11. Let me flip where's my page at? Oh, right there. 36 is times 11 is 396. And x times 10 is 10x. So we divide both sides by 10. So x is equal to 39.6, and that rounded to the nearest tenth. That's what we got. All right, so number 11. So, and I know how you guys are. You guys use Goth or whatever, the AI math. Bring me the right answer. So the reason I say that, because I got in an argument with AI, and I have screenshots to prove it, and I was right, and I want to see. It kept giving me the wrong answer, even though I corrected it, and I'll show you guys at some point. So let's flip over page 8. Time's a wasting. Yeah, 8 is the last of this page. So I'm going to go ahead and do the next video here shortly. So I'll finish off module 10 tonight. But this will finish off topic 6 in this video. So number 12. I'm going to solve for x. So where is x? So x is here. So how do we set this up? So this guy, it's a secant and a secant, and they intersect outside the circle. So we know that the product of this times this is equal to this times this. Or, let me write it for you, AB times BC equals AE, AE, sorry, I got times ED. So now we just, and just to make it pretty, we'll say, here's your AB, here's your BC, AE is right here. And since we made the X green, we'll make this guy green. All right. So we just plug in. So we got 5 times 10, because this is 5, this is 10, equals AE is 4 times ED is X. All right. So 4 times X, 4X. 5 times 10 is 50. Divide both sides by 4. I'm just going to flip-flop this, but X. What in the world? What did I do? Okay. All right. Actually, yes. Messed it up here. So it's AC and AD. So let's do this. It's this. Well, yeah, this green times yellow, and then we'll make purple times, so it's purple. So yeah, give me just a second. And dadgummit, of course I didn't I didn't do it in pencil, so that's what I get. So this is 15, because AC is, this is 10 plus 5, and this is going to be 4 plus x. This was 5, and this was 4. So 4 times 4 plus x, or x plus 4. We'll just say x plus 4. So 5 times 15 is 75. Over here, we're going to have 4 times x is 4x plus 4 times 4 is 16. So we're going to subtract the 16 from both sides again. Sorry for all the mess. 75 minus 16 is 59. Okay. It's equal to 4x. Divide both sides by 4. So 59 divided by 4 is going to make x 14.8. That looked way too pretty, and I'm sorry about that again. So let's got to the right, number 13. Solve for x. X is out here. So this is going to be the one we square this guy. It is going to be equal to the purple, since we made the x purple. And then the whole thing is pink. You still see the purple, I hope. So I'm going to write in pencil. So AB squared, see this guy squared, equals, hang on one second. Bruh. Okay. So AB squared is going to be equal to AC times AD. So this piece times this piece. Right? Right. So when we go over here, it's 7 squared equals AC x times x plus 12. Because this whole line is x plus 12, remember, the whole thing. Just happy little accidents. All right, so 7 squared is 49. X times x is x squared. Plus x times 12 is 12x. Okay. So we're going to put this into a quadratic equation. So we're going to subtract 49 from both sides. So we end up with x squared plus 12x minus 49 equals 0. And some of you guys, this is going to be digging way back, so we're going to put this into the quadratic equation, and then that's how we're going to solve it. So the quadratic equation is negative b plus or minus the square root of 4 times a, where's it at? Oh, God, I had this thing memorized forever. 4a, hang on. Let me pause just a second. This aggravates me. Okay, I'm sorry. As you can tell, I've corrected this. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And you guys are like, what are you talking about? So let me show you a couple of things. So for this problem, so for number 13. So, oh my goodness, sorry. So this right here, this is how I told you we were putting it in the quadratic equation. So x squared plus 12x minus 49. X squared plus 12x minus 49. So a goes with your x squared. Since there's nothing there, that's a 1, right? So a equals 1. B is what goes with your x. So b here is 12. And c is your number that's by itself. In this case, it's a negative 49. Okay? So we're going to just work this underneath, and then I'm going to remove these to go forward because I'll need the room. All right, so in this case, so x equals negative b. So negative 12 plus or minus the square root of b squared, so negative 12 squared, minus 4 times a, which is 1, times c, which is negative 49, over 2 times a, which is the 1, you know. Okay, so negative 12 plus or minus. So negative 12 squared is a positive 144. So let me get the calculator so I can prove to you guys I'm not lying. So over here we have, well, negative 4 times 1 times negative 49. So that gives us plus, because that, see, I'd already messed it up. So 196 over 2 times 1 is 2. So negative 12 plus or minus. So we add these two. So we got 340, over 2. And so I'm going to try this. And I keep getting it backwards, but we'll try it anyway. So negative 12. What did I just do? Nope, stop. 12. So you try it plus. We should get one negative and one positive. A length can't be negative, so we go with the positive, but something I'm doing is wrong. And I keep getting both negatives, but I know which one it is, so I'm just going to show you guys. So you turn this into negative 12 plus or minus the square root of 340 over 2. And we're going to show what x equals. So times, nope, wrong. Go back again. So plus, so 340 square root, that's what that number is, divided by, well, yeah, that's what that number is. So equals 6.4 divided by 2. All right, so x equals 3.2. Excuse me. Now maybe I figured it out. So negative 12 minus 340 square root equals, so we got a negative number divided by 2. Yeah, so one's negative, which is no bueno. So our answer was the positive one. So it ended up just being plus. But for either way, x equals 3.2. So let me move these out of the way. Okay. All right, 14. Trying to finish this up. Sorry this is such a long video. It's a long topic, guys. So find the measure of PT. I'll try to speed it up a little. PT. So they want PT. So we got PT in there. This guy over here. And this one over here. All right, so we learned that yellow times pink, PT times TR is equal to ST times TQ, which I could have made them, it doesn't matter though. So PT, 2x plus 2. So we're going to solve for x, and then we got to plug it back in. Times 5 equals, ST is x plus 5 times 6. All right, so we got to distribute this. So 5 times 2x is 10x. 5 times 2 is 10. Should have put them in the front, but 6 times x is 6x. 6 times 5 is 30. Now we're just going to subtract 6x because it's smaller. 10x minus 6x is 4x plus 10. 30 comes down. Subtracting the 10 from both sides. I'm just going to move up here. So 4x, these guys canceled, equals 30 minus 20. 30 minus 10 is 20, Lord. Divide both sides by 4. X equals 5. They want PT. So PT equals 2x plus 2. So 2 times what was x? X was 5 plus 2. That's 10 plus 2 is 12. So PT equals 12. All right, moving right along. Sorry. It's a long video. Okay, 15. Solve for the measure of AB. So for this one, this is where this guy times this guy. So the whole thing. So I just messed that up. This is 8. Oops, all right. And then well, we'll do the whole thing green because it's going to be the outside. Where is my only other color? This one. So brown is just from there to the edge of the... let's hit it again. X. Okay. All right. So in this case, AB times AC is going to equal AE times AD. So this piece times the whole thing, this piece times the whole thing. And now you know why we've been learning segment addition and all that other good stuff. So we could talk about this great stuff now. So AB is x plus 2. This is AC is this plus... How do we do that? All right, I'm going to go with it. So if this is x plus 2, this whole thing is x plus 2 plus 8, which is x plus 10. Don't ask me, I don't make the rules. So AE is x times AD, so this is x plus, so 2x plus 4. Make sure. Which one am I on? X plus 10 and x times 2x plus... Okay, yeah, I'm right. All right. So we're going to FOIL this. So x times x is x squared plus the inner, well, outers, 10 times x is 10x. Inners is 2 times x is 2x, and then 2 times 10 is 20. Over here, x times 2x is 2x squared plus x times 4 is 4x. All right, so let's combine these. So we've got x squared plus 10x and 2x is 12x plus 20, 2x squared, 4x. So let's just subtract both of these from both sides. Okay, and we're going to move it up here. So x squared minus x squared, those cancel. 12x minus 12x, those cancel. So it's 20 equals, so 2x squared minus x squared is x squared. 4x minus 12x is negative 8x. So now we're going to move this guy over here. So subtract 20. So now we have x squared minus 8x minus 20 equals 0. So more sticky notes. So again, it is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2 times a. You see we're getting into this over here. So here's our thing. It's x squared minus 8x minus 20 equals 0. Your a goes with your x squared. I'm making it bigger. Your b goes with your x, and then your c is the number here. So a in this case is 1, b is negative 8, and c, negative 20. Okay, well, I know we're covering up stuff, and I apologize, but it is what it is. So we'll just scooch there. So, all right, so let me finish this up. Let me move this a little. All right, so again, negative b x equals negative b plus or minus square root of 4a, b squared minus 4ac over 2a. So b is negative 8, so it's positive because this is a negative, plus or minus the square root of negative 8 squared minus 4 times a is 1, c is negative 20 over 2 times a, which is 2. Or, 2 times 1 is 1. All right, so we got 8 plus or minus. Now we know this is 2 over there. So 8 squared is 64. I'm going to write the minus, but it may change. Negative 4 times 1 is negative 4. Negative 4 times negative 20 is positive 80. So this is 8 plus or minus the square root of 144. Getting into a real number, over 2. So let me go one further. So hold on, let me write this on here. So 8 plus or minus 1. Okay, sorry, I had to be able to see it. Okay, so this is 8. So square root of 144 is 12. So it's 8 plus 12 over 2, which is 20 over 2, which is 10. Or if we go 8 minus 12, we got a negative number, because that's negative 4 over 2. So it's negative 2, and we can't have a negative distance. So all that to say the answer for this guy is x equals 10. I'm going to keep all these sticky notes. I'm sorry. You guys are going to be so mad at me tomorrow. And I can't help it. All right, last question. And again, I have to do this like several times. So, this is a secant. Secant. No, tangent because this touches it once. Secant because this touches it twice. This side. And then this. So it's going to be the square of, so JK squared is going to be equal to JM times JL. So we switch to pencil. So 8 squared, which is 64. So JM is X. JL is X plus 10. So X times X, X squared, X times 10, 10X. Guess what? We're moving this over. So now we have let me just, all right, so we'll have room to write it here. Down here at the bottom, x equals negative b plus or minus square root of b squared minus 4ac over 2a. So all that, so remember the a, the b, and the c. So x x equals negative b, so 10 plus or minus the square root of b squared. So 10 times 10 is 100. I'm just going to go ahead and square it. This squared times 4 times a, which is 1, times c, which is negative 64. So I still got to come down anyway. So negative 10 plus or minus the square root. So we've still got 100 over here because we have to do all this math over here first. So don't let that fool you. So yeah, let me just do this. 10 squared, which is 100, but so 4. Wait a minute. No, it's minus, not, yeah, sorry. So 100 minus, well, we'll see. It may change. So minus 4, negative 4 times 1 times negative 64. So it did turn positive. Oh, and it was over 2a, which 2 times 1, so over 2. So we're going to go down a little. Wow, Lord, goodness. Sorry. I'm so sorry. So x equals negative 10 plus or minus the square root of 356, all divided by 2. So let me show you over here, and I apologize. It's going to get all wonky. So negative 10. We're going to try the plus first. Plus 356 square root. So equals, we divide that by 2. So that's a positive 4.43. 4.43. I'm not going to wait yet. Let's try so negative 10 minus 356 square root equals, so it's a negative number. So this is it. All right. Sorry for the long video. Believe me, it pains me too. I promise. So, I've got any questions, and I'm sure you'll have them. Send me a message in Focus. Reach out. Ask me in class. Till next time, have a good night.